We'll be solving the problem book arrangement challenge. So in this we'll be given n books and we need to arrange the books in the order of the publication year in ascending order, that is from the earliest to the latest. Now we have to follow some protocols. We can only take one book at a time from the shelf and we can only place it either at the very beginning or the very end of the shelf. And the order of the remaining books does not change during this process. Given the initial arrangement of the books, we need to find the minimum number of moves to sort the entire collection in ascending order. For the input format, we have the first line which consists of integer t, which is the number of the test cases. For each test case, we will be given an integer n, the number of the books, and n space separated integers representing the publication year of the books. For the constraints, the test cases can only range from 1 to 20,000 and the number of the books can only range from 1 to 200,000. The publication year can range from 1 till 10 raised to 9. All publication years are distinct and the sum of all n across test cases does not exceed 20,000, 200,000. So for the sample input, we are given 1 which is the number of the test cases and 5 which is the number of the books. So here we are given the publication year of the 5 books. So let me explain you the sample test cases. So here I have arranged the sample test cases in the form of an array. So this is the initial arrangement. Now to make it into ascending order, we will follow the steps. Now we will pick 1991 and place it at the end, making sure that the arrangement of the other books does not change. Then we will pick 1997 and place it at the end. Again, the arrangement of the other books should not change. Then we will pick 1975 and place it at the beginning. And we can see that the books are now in ascending order. So we will stop and so therefore the total count becomes 3 and therefore we will output the number 3. So now let's take a look at the approach 1, which is the brute force approach, where we will trying every pair and check for the increasing subsequence. So as for the approach 1, the first approach that comes to mind is to find the books that are already at the correct position, and then we will subtracting the length of the book and the number of the books that are at the correct position to get the number of the books which are at incorrect position. So here, as for the brute force, we will be taking every book and we will be comparing it with the books ahead of it. If it is greater than it, then we will have a count variable which will help us in keeping the track of the books which are greater than it, and the which is the increasing sequences, and we will keep a track of the maximum of those. Now we will do n, which is the books array of books dot length, and we will subtract the maximum LIS to get the number of books which are at the incorrect position, uh, which will be the answer. Now since this is using two for loops, the time complexity becomes big of n square, which is very bad. So we will try to optimize it. So for the better approach 2, we have a greedy approach, which will have a time complexity of n log n. So let's take a look how to implement it. So now let's take a look at the code for the greedy approach. Firstly, we'll be importing all the Java utilities. We have a class named solution. As for the main method, we'll be taking input the scanner object SE, and which will be helping us in taking the inputs. We have an integer t, which is the number of the test cases. For each test case, we'll be calling the function min moves, and which will be taking input the scanner object SE. Then we will close the scanner. Then we have a simple container class named pair, where publication year is stored as value and it's the index in the original input is stored as index. For the function min moves, firstly we will be reading the value n, which is the number of the books. Then we will be creating an array of pair objects, uh, where value is the publication year and index represents the original index in the input. Then using the for loop, we'll be storing the values in the pair array. Then we'll be sorting it using the comparator class based on the publication year. And here we have res, which stores the length of the longest valid increasing sequence. Prev, which keeps track of the last book's original index in the sorted array. And then uh, val, which stores the current length of the increasing sequence of original indices. We will be running the for loop from 1 till n minus 1, and we will be checking if the index, that is the prev, is less than the index of the current element in the pair array. If so, then we will be incrementing the val by 1, and will be taking the max of res and val and storing it in res. Else, if no book is found, that is the book does not keep its original order, then we'll be resetting the value of val to 1. Then we'll update the previous index to the current element index, and after everything is done, we will have the value res, which represents the number of the books which are at their correct position according to the publication year. Now subtracting n from it gives us the books which need to be moved to make it correct. That is the number of books at incorrect position. So we'll be printing it. As for the approach 3, we'll be using the same thing but using binary search. So for the code, we'll be having a method min moves which will be taking input the array books. Now we'll be performing binary search to find the right position to insert the current book. We'll be iterating through the entire array books, and we will checking for each element the position. If it is in the right position, then it will be a positive value. But if the position is not found, then binary search returns a negative value, and the index where it would have been if the array is would have been sorted. So if the position value is negative, then we will do pos is equal to minus pos minus 1 to get the positive value of where it should be. Then if it is greater than all the elements, then we will append it to the end, that is lis.add here. Otherwise, if it is not greater, then we will replace the element of at that position. Now LIS represents the maximum number of books that are already in order. So to find the minimum number of moves, we'll need to find the books which are at incorrect position. Therefore, we'll be returning books.length minus lis.size. So these are all the three approaches. Thank you.